As the universe expands, do you, me, this device you are watching this video expands too? Well, even if you are not sure about yourself, a black hole does. In 2015, LIGO observed two black holes being merged for the first time. Since then, astronomers have been repeatedly surprised by their large masses. But merger emitted no light, so the observations had to be made through their emission of gravitational waves. Gravitational waves are the ripple in the fabric of space-time that were predicted by Einstein's theory of general relativity. In 1939, it was estimated for a star to become a black hole, it needs to be 0.7 solar masses. It was called TOV limit. In 1996, a different estimate put this upper limit in a range from 1.5 to 3 solar masses. But in the theory of general relativity, a black hole could exist in any mass. Till now, scientists believed black holes to have masses less than 40 times that of the Sun. Because merging black holes are derived from massive stars which can't hold them together if they get too big. But astronomers at LIGO and Virgo observatories have detected black holes which have greater mass than 50 suns and some with more than 100 suns. So, a new idea about the formation of black holes have been proposed. All the studies till today have proposed several formation scenarios, but none of them can explain the diversity of black hole mergers observed so far. And also, they cannot agree whether the formation scenarios are physically possible. Well, it has been observed, so it's possible in nature, but we were wrong. A new study was published in the Astrophysical Journal Letters that may have just solved the problem. The study was done by researchers from University of Hawaii at Manoa, the University of Chicago, and the University of Michigan at Ann Arbor. The study suggests that black holes may have grown along with the expansion of the universe. That will explain why larger black holes are very far from us and why they are much older. There used to be no study that could explain the birth of small and large black hole from a single pathway. The time it takes for a black hole to emerge from a star and then two black holes eventually merging with each other, the universe expands profoundly. Now, if we take the very subtle aspects of Einstein's theory carefully, then a startling possibility emerges. The masses of black hole could evolve equally with the universe, which is a phenomenon that astronomers call cosmological coupling. This single parameter encodes the cosmological mass growth of compact stellar remnants that exceed the Tolman-Oppenheimer-Volkov limit. If you want an easy example of cosmologically coupled material, then light is the best example. It loses energy as the universe grows. But how did the astronomers investigate this hypothesis? They did it by stimulating the birth, life, and death of millions of pairs of large stars. Any pair where both stars died to form a black hole were then linked to the size of the universe starting at the time of their death. As the universe continued to grow, the masses of these black holes grew as they spiraled toward each other. The result was not only more massive black holes when they merged, but also more mergers. When the researchers compared the LIGO-Virgo data to their predictions, they agreed reasonably well. The LIGO-Virgo population of merging compact remnants provide an unprecedented window into compact object physics. Compact objects with realistic cosmological boundary conditions can experience new dynamics in time. Scientists have shown this signature of cosmological coupling can be directly measured from the rate of orbital period decay and may be accessible to the next generation gravitational wave observatories. Well, this is a great time to say a star in the Orion constellation is going supernova. And how can this newly discovered planet orbit 3 stars altogether?